We're still on our way to building a production function which we can use to model real GDP and make predictions about economic growth. So far, we know that our two inputs are capital and labor, and that our production function should exhibit diminishing marginal returns when we hold one or the other constant. Since the Industrial Revolution, however, capital and labor have gotten more complicated. In Solo's original model, they were treated as exogenous parameters, meaning they were not determined by anything. They are just chosen by the economy. Later, economists started to consider these variables to be endogenous, or variables which are determined by other factors. You'll remember that as the Industrial Revolution got underway, innovation led to improvements in the productivity of capital. Machines got better and better, increasing how much output a single machine was able to assist in making, which also made labor more productive. Innovation leads to higher productivity all around, and the degree to which labor and capital are able to produce output changes with it. We want to incorporate innovation into our production function. But unlike labor and capital, new ideas don't have diminishing marginal returns. As we have seen, the returns to new ideas can even be exponential. So we want the variable for it to appear outside our mathematical function, like this. The variable A represents ideas, specifically ideas which increase the productivity of labor and capital. These ideas are multiplicative with our production function because innovative ideas are able to magnify total output. As we improve our stock of knowledge, innovate new and better machines and production processes, and find better ways of mixing our resources together, we increase our value for A. Since it affects all factors of production, sometimes this gets called total factor productivity. Another important change is that jobs in these modern economies require lots of skills, meaning that workers need more education in order to do the work that needs to be done. More education builds our stock of skills, and you can see that over the past 1.5 centuries, educational attainment has risen from virtually nothing to a couple of decades of schooling on average. There is also good reason to believe that investments in education may result in increased worker skills and greater productivity of labor. We want our model of the economy to recognize this. So, the L in our production function needs a companion. It isn't just blood, sweat, and tears that gets the work done, not just raw human labor, but rather labor paired with our education. Together, education times the labor supply gives us what we call human capital, or the stock of worker ability. Notice there are two ways to increase human capital. We can increase the quantity of labor in the economy, or we can increase the education level of our workforce. We can work harder, or we can work smarter. But H is what we want now in our production function, representing the pair. These modifications endogenize our modern sources of growth. They incorporate innovation and education, rather than leaving them as something external to production. So, now that we have all our pieces, what equation should we choose for our function? There are a lot of different choices we can make, but the most common is called the Cobb-Douglas production function, named for the two economists who developed it. It's quite simple. Output, Y, is equal to total factor productivity, A, times capital, K, raised to the power of alpha, times human capital, H, raised to the power of beta. Alpha and beta are just placeholders, and the numbers we choose to put in for them represent the share of output attributable to capital and labor respectively. To exhibit diminishing marginal returns, both alpha and beta need to be less than 1, and usually we pick numbers that add to 1 for convenience. For example, we might set alpha to 1/3 and beta to 2/3. This would mean that capital is doing about 1/3 of the work in the economy and labor is doing 2/3 of the work. Since there are ways to estimate those shares, the Cobb-Douglas production function matches reality pretty well. Now that we have this fantastic little toy economy, which is able to take in ideas, capital, education, and labor, and turn them into real GDP, we can go about making some predictions about economic growth. But we will need a few assumptions about how capital gets created first.